In this video, we're going to show you how to record arrow data. The data we're going to record is going to be the static spine of the arrows, the total indicated runout, which is related to the straightness advertised by the manufacturers, and the grains per inch. The materials needed are a weight calibration set. This is to confirm that we are using exactly 880 grams of weight on our spine tester. We're going to be using a spine tester, either homemade or store-bought. Of course, you're going to need your arrows. We're going to need a scale that can weigh in excess of 880 grams. A smaller arrow scale for weighing our arrows, and a notebook for recording our data. The most important thing when measuring the static spine of an arrow is to ensure that we're applying exactly 880 grams of weight to the arrow. So that's where the weight calibration set comes in. We want to verify that this scale is going to work for what we're doing. So we're going to go ahead and turn this on and see if the scale's off. Here we're going to apply 880 grams. There's a 500 gram weight and it's reading 509. Add 200 and we're up to 713. As you can see, the scale's off, so we're going to go ahead and add all the other weights to equal 880. And we're coming out to 897 grams. So we know right off the bat that this scale is approximately 17 grams off. So what we want to do now is we want to ensure that this weight that we're going to apply to the arrow with the weight of the indicator scale pin equals 897 grams on this scale. So we already know that the indicator scale's pin weighs exactly 16 grams. So 16 from 897 is 881. So this lead ball needs to come out to 881 grams. And as you can see, we're right at 881. So now we know with the indicator scale's pin plus our weight, we're exactly at 880 grams. The next thing you want to do in the process is to number your arrows. As you can see, I already did that here. This is shaft number 7. 9, 8, so on and so forth, 1 to 12. Next thing you want to do is set up your notebook for recording the data. As you can see here, we have the name of the arrow. This is a Carbon Express Nano Pro RZ350. I have the arrow numbers right here, 1 through 12. Here's our degree marks. We're going to measure each arrow in 4 different spots. At the 0 degree mark, 90, 180, and 270. We're going to record the spine under each one of those columns there. TIR is for total indicated runout. That's going to tell us the straightness of the arrow. TW is the total weight of each arrow. Below that we have the advertised specs versus measured. The advertised grains per inch for this arrow shaft is 9.6 grains per inch, and we will record a measured when we're done with our recordings. The advertised spine is 350 thousandths of an inch of deflection, or let's just call it 350. Here we'll put the average measured spine when we're done recording. And then the straightness is 1.5 thousandths of an inch, or for total indicated runout, that could be up to 3 thousandths of an inch in total indicated runout. And we will see what it actually scored here. So the first recording we're going to do is going to be the total arrow weight. So we have arrow shaft number 1 right here. We're going to go ahead and place that on the Last Chance Archery arrow scale, which is probably one of the best arrow scales on the market. And right here we're coming out to 316.5 grains. So we're going to go ahead and record that. Arrow 1, 316.5 grains. And at the end we're going to divide that by 33 and find out what our grains per inch is compared to the advertised grains per inch. Next measurement we're going to do is the total indicated runout. And to do this, take your arrow and put it on your spine tester, and you're going to rotate the arrow shaft 360 degrees and watch to see if this needle moves at all. And if it does move, we're going to record how many thousandths of an inch it moves. Well, these Carbon Express Nano Pro RZs are super straight. As you can see, that needle isn't even moving, although we are rotating the shaft. So For a better example of this, well, this recording is going to be 0. We're going to put a lesser arrow on there and see what this one reads. This is a Cabela's brand arrow. So, start the rotating. And this one's about 10 thousandths of an inch in total indicated runout. So I would record that under the TIR column as 0.010, and that would be its recording. All right, now it's time to start measuring the static spine of the arrow, and to aid us with measuring it at 0, 90, 180, and 270 degrees, we're going to take a knock and put a solid black line on one of the faces. So there that is. So when we put it in the spine tester, this will be at the 0 degree, this will be at 90, this will be at 180, 270, and that's your 4 measurements. So let's go ahead and get to it. So now to begin measuring the static spine of the arrow, we're going to take our arrow with the knock installed. We're going to put that black line up, load the arrow into our spine tester. Now what we're going to do is we're going to raise the indicator scale's pin and zero out the indicator scale right when the pin is touching the carbon. So in this situation, it's right about there. So as you can see, just the weight of the pin itself is deflecting the arrow about 10 thousandths of an inch. Now we're going to take our weight and we're going to apply it to the arrow. And we're going to count the revolutions. There's 100, 200, 3, and we're going to take our fingers and just settle the pin. So the first reading at the 0 mark is 348 thousandths of an inch. Now we're going to ease up on the weight, and we're going to rotate that knock towards us 90 degrees, and we're going to drop the weight back down. 1, 2, 300. And this one is 352 thousandths, and that's for the 90 degree mark. Now for the third measurement, we're going to rotate the knock another 90 degrees. And there's 100, 200, 300, 348. So the measurement for 180 degrees is 348. Now for the final measurement, we're going to rotate the knock 90 more degrees and lower our weight and count the revolutions. 1, 2, 3. And this measurement comes out to about 349 thousandths of an inch of deflection for the 270 degree mark. Now that we have all our data, we can see how these arrows did. You'll see to the left I added a column of average spine. And the average spine came out to, for the dozen arrows, 346.9. We could round that up to 347. And that's within 3 thousandths of an inch of deflection of the advertised 350. So they did really good there. The total weight divided by the total length of the arrow of 33 inches came out to 9.6 grains per inch. And of course we rounded to the nearest tenth here. So that was spot on. The straightness, they guaranteed it to be within plus or minus 1.5 thousandths of an inch of straightness. Well, these were super straight, so no problems there. We only had one arrow that moved the needle considerably, but that's still really good. So what can we do with these numbers? We can now cull our dozen arrows down to our best 6, and you'll see the best 6 that I have here is highlighted in orange. What I did is I got rid of the worst straightness. And then I culled some of the stiffer readings on the spines and kept the ones that were closer to 350. But more importantly, I wanted to keep them within a couple thousandths of an inch in deflection. So we got 350, 349, 348, 348, 348, 349.25. So these 6 arrows are all within 2 thousandths of an inch in deflection. So when they're all built, they should have practically the same dynamic spine, so they all should tune very similar to each other. These numbers also may help you realize why an arrow or two won't fly like the rest of them. Take this oddball here, arrow number 4. It had a spine of 341.5. So that's the stiffest out of the group. And if you didn't have these numbers here, you may find that when you're nock tuning these arrows, this one might not have the same point of impact as the other ones, or it may fly not as straight as the other ones. But what we have here is data, and it's something to go off of, but definitely you have to build the arrows, take them to the range, see how they tune themselves, just to verify that these are your best arrows. So hope this video helped. Thanks for watching.